4. This first part of this is, if you go over to lesson 63, this is going to be equations of a circle, which we should already know. We should already know what the equation of a circle looks like, right? That's x minus h squared plus y minus k squared equals r squared, right? Yes? Heads bobbling up and down? Yeah. Okay, so they're going to give us a different form of the equation. We're going to have to change that back into the standard circle equation form, and then be able to graph that, which the graphing portion isn't all that bad once we get it into the correct format. And getting it into the correct format just takes a couple simple steps. All right, you guys have this page up, correct? Okay, so I'm going to move on to a blank work page, if it'll let me. Okay, so we're going to take that equation, which is, right now it's x squared plus y squared minus 4x plus 6y plus 9 equals 0. All right, so the first thing we're going to do is, because this is all plus and minus, is that we're going to use the commutative property. We're going to move things around. We're going to move our x's together, and we're going to move our y's together. So we're going to rewrite this as x squared minus 4x. I'll get all this correct here. Plus y squared plus 6y. And we're going to move our 9 to the outside. Okay, so that's going to be equal to negative 9. Okay, now one of the things it says in this, it says solve this circle by completing the square. So what we're going to do is we're going to take each of these individual sections here and here, and we're going to complete the square, which means what am I going to do with that negative 4x? I'm going to take that negative 4 divided by 2 and square it. Okay, I'm going to take this 6 divided by 2 and square it there. Okay. All right, so this is going to be x squared minus 4x. What's negative 4 divided by 2? Negative 2 times negative 2, positive 4. Okay, so I've got this, right? We're going to take this negative 9. We're also going to add 4 over here. Okay, then we're going to do the same thing with our y squared portion of it. So we've got 6 divided by 2 is 3. 3 squared is 9. So this is y squared plus 6y plus 9. Okay, over here we're going to add that 9 there. So what ends up happening with the 9s? They cancel out. I'm left with 4. Okay. Now we can take this, simplify this down. It becomes x minus 2 squared, right? Do we understand how to get that? Okay. Plus y plus 3 squared equals 4. So we can really easily graph this. In fact, I'm not going to graph it. Where are the coordinates? Well, I mean, we can do it well enough, I guess. Where are the coordinates of the center of that circle going to be? 2, negative 3. So we're going to go right 2, down 3, 1, 2, 3. There's my center, right? My radius is what, though? What is my radius? No. What's my radius? 2. Because the equation of a circle is x minus h squared plus y minus k squared equals r squared. Because that's not 4 squared, it's 4. What do I have to do to find the radius? Square root it. So my radius is 2. So, you could rewrite this out so that you have your information. So you're looking at 2, negative 3 for my center, radius of 2. Right, and I didn't do a really great job with this, but I'd go, up 2, over 2, right 2, down 2, so I'm seeing a circle about right there. Okay, does that make sense on how to do that? Okay. All right, let's see, what I'm going to do then is I'm going to hit pause on the video, I'm going to let you guys work out question number 2, right? Pick the right graph based upon that. Okay, does that make sense? All right. So I'll leave this up on the board for you to be able to kind of follow those steps from. My mic is on. So the answer on number 2, just so I'm getting that portion of it recorded, is D. You should have gotten x plus 6 squared plus y minus 3 squared equals 9, giving you a center of negative 6, 3 with a radius of 3. On 3 down, we're talking about lesson 64. Lesson 64 takes place over on page 412. We're talking about complex planes, polar form of a complex number, sums and products of complex numbers. So not necessarily an easy portion getting into 64, which is why tomorrow is a work day in the event that we don't get all of this covered as thoroughly as I'd like. So when we're talking about the polar form, there's really 2 forms when we start talking about coordinates. There's rectangular form, which is x, y, and there's polar form, which is hypotenuse angle. Okay, so rectangular form is what you see here, is this 2 plus 5i. Okay, that's the rectangular form of the coordinate. Okay, essentially what that means is that I'm going 2 to the right, 5 up. Okay, does that make sense? Now this is on a complex plane because what you're seeing is I is a complex number. Does that make sense? So we're on the complex plane dealing with this. I'm going to the right, 5 up. What the polar form is it is my hypotenuse with an angle. Typically it'll either look like this, where my hypotenuse goes here and my angle goes here, or it'll be hypotenuse cis angle, where cis basically represents what comes after that is my angle form. Okay, this is the polar coordinate. All right, do we see somewhat of the difference there? Okay, so it says determine the polar form of the complex number 2 plus 5i. Express your answer. Express the angle theta in degrees. It's got to be between 0 and 360 around the numerical entries to answer to 2 decimal places. So you're going to hold on to that. I'm going to shoot out over here, rewrite that. So 2 plus 5i, okay, means essentially we have something that's going to look like this. Now remember, in the polar form, that number that comes out over here is the hypotenuse. We should be able to figure that out, right? All right, so 2 squared plus 5 squared equals c squared, right? Okay, 4 plus 25, so square root of 29, right? Right, but we're not going to want just a square root of 29. They're going to ask for a decimal number. Let's go ahead and get that to 2 decimal places. What is the square root of 29? 5.39. All right, and they're going to want the reference angle. But I don't want to use a found number. I want to use specific numbers, and so the certain numbers that I have are the numbers that they're going to give me. So in relation to my reference angle, what trig function would I use? Sine, cosine, or tangent? Tangent, because 5 is opposite, 2 is adjacent. So what we're going to do is, because we're looking for an angle measure, we're going to use the inverse tan, okay, 5 over 2. Make sure that my calculator is in degree mode, okay, and then get that angle to the nearest hundredth. I would do 0.20. So this is our polar form, or we could have written it as 5.39 cis 68.20 degrees. Okay. That's it. That's it for that. Now, these do get increasingly more complex. They're starting out fairly easy. This is kind of an introduction to polar coordinates today. Okay, so like let's say whenever we go back to question number 4, for instance, convert 5 cis 60 to rectangular coordinates. Okay, well, if we're doing that, then we already know certain things, right? All right, so if they're telling me I have 5 cis 60, right, what that means is that my angle is at 60 degrees, right, and that my hypotenuse is 5. Okay, so this is 5. Now what's handy about this is that it's 60, right? Why is that handy that it's 60? 30, 60, 90 triangle. So we know what our ratios are at that point, right? So it goes 1, 2, radical 3. So what am I going to do to find my x coordinate? No. Divided by 2. It's going to be 5 divided by 2. Remember, 30, 60, 90 ratio in this case is x, 2x, x radical 3.
Oh, I was thinking of 45.
Yep. All right, so my x value there is 5 halves, right? Okay. Plus, let's see, would be 5 halves radical 3, right? And we're going to put, because this is complex, we're on a complex plane, that's going to be I. Okay? That's pretty easy because it's a 30, 60, 90 triangle, right? Right? It'd be a little different. If you were wanting to do this outside of using 30, 60, 90 to find these, do we want to see how to do that, like in the event that it's a different degree? Yes or no? Okay. I'm going to assume yes. So in this case, if I was trying to find, let's say, well, let's call it y, because that's really what it would be. If I wanted to find that, right, then what I would do is I would do sine 60 equals y over 5, so 5 sine 60. Right, and that should give you y. So if we type that in our calculator, 5 sine 60, 4.33. So we know that we're winding up with, of course, in our y, that's 5 radical 3 over 2. So we want to be able to get the radical if we can. Okay, so pay attention when it's 30, 60, 90, or 45, 45, 90. You know, our special right triangle ratios are going to be more exact answers than our decimals. Okay, so really even easier yet would have probably been to go to x on that and get the adjacent. So, you know, cosine 60 x over 5, so 5 cosine 60. 5 cosine 60 should come out to that 5 halves. So that's actually a better place to start from, is getting that x value. Once I see something where I have a firm fraction or decimal, then I can go based upon that. Okay? All right. So that was 4. Okay? 5, and I know this kind of gets cut off here, but it says determine the polar form of the complex number 3 plus 3i. Express your answer in degrees. So I kind of want to see how well you guys do at this. Okay, we have 3 plus 3i. So if I go to draw this, how far to the right am I going? How far up am I going? 3 and 3. Right? That ought to tell me what kind of triangle this is going to be, right? What kind of triangle is this? 45, 45, 90. Right? So I already know, right? That actually makes my job a lot easier, correct? Because I already know what my hypotenuse is going to be, correct? Because we're looking for polar coordinates. So what's the hypotenuse of that? So you said what? Radical 18? Well, it would be, if it's 1 radical 2, it's going to be 3 radical 2, right?
Yeah.
So if I'm looking for the decimal, all I have to type in my calculator is 3 radical 2, right? What's 3 radical 2? 4.24 cis. I already know what the reference angle is, right? It's 45 degrees. So they're keeping this pretty simple at this point, right? But you did see on question number 3 how to find that angle, right? Right? All I would have to do is do tangent or inverse tangent 3 over 3. And if I do that in my calculator right now, second tangent, 3 divided by 3, 45 degrees, right? All right. And so let's see, that's 5, which brings us down to 6. And let's see, let's kind of, oh, I guess I could have scrolled on from there. Right, and let's see. So we got 4.24 cis 45, so we got D for 5. 6 says we want to multiply radical 3 cis 60 times negative 2 radical 3 cis negative 15, so this gets a little bit more complicated. It's a little different. I don't even think that it's overly difficult. Okay. All right, so we'll take this and we'll move to the next. All right. All right. We got radical 3 cis 60 times negative 2 radical 3 cis negative 15 degrees. All right. So the things that we actually multiply here are our hypotenuses, hypoteni. Okay, radical 3 times negative 2 radical 3.
Isn't it just -6?
Well, radical 3 times radical 3 is 3, times negative 2 is negative 6. So we know we're going to get negative 6 in there. The next portion on this is my 60 and my negative 45. And actually in that, all we're really doing is we're adding those. Okay, you don't actually multiply them, you add them. So what's 60 plus negative 15?
Let's go up to 75. Oh, yeah.
45. Yeah. Oh, try not to reference. All right, so what this question actually asks for, though, it says in number 6, express your answer in rectangular coordinates. What do I have this in? I have it in polar coordinates, right? Oh, goodness. All right. So, polar coordinates, all right, if we're at negative 6, right, and we're at 45 degrees, this is the first time we actually run into a negative hypotenuse, right? All right, so 45 degrees actually puts me in the first quadrant, correct? So whenever I have a negative hypotenuse, I'm in the opposite quadrant. That's how I get a negative hypotenuse. So I'm actually down here, 45 degrees. That's how I get a negative 6 there, okay? So now, because I'm looking for rectangular coordinates, I'm looking for this guy and that guy right there, all right? So what we're looking at is we've got negative 6. How do I find these other parts? Well, because it's 45, 45, 90, right? We know we're at 1, 1, radical 2. So if I just take 6, negative 6, divided by radical 2, right? Does that ring a bell?
Yeah, it does say.
All right, so then I'd multiply by radical 2 over radical 2, right? I'd get negative 6 radical 2 divided by 2, which is going to come out to what? Negative 3 radical 2. All right, so negative 3 radical 2. And because I am left and down, I'm actually getting, and because it's 45, 45, 90, they have the same lengths, right? So I'm actually at negative 3 radical 2 minus 3 radical 2 I. That's my answer.
Oh. The I, like the imaginary number, why does that go
because we're dealing with complex numbers, because it's complex, it's on the complex plane.
Would, would, wouldn't that make the -3 positive this week?
No, no. Your y position in these will always be I.
Oh,
Okay? We just put the I on at the end, so don't let that confuse you. Okay? It won't affect or change your answer. Okay? All right, so let's look at number 7. I'm not going to go back to the main page and look at it. You guys already have that kind of sitting there in front of you. You might have to flip pages. But it does say, and I think, what, you guys get out of here at 8:50? Is that right? All right, so the bell will probably ring before I really get into this. But if we're at, let's see, -2, cis 75. All right, so let's change things a little bit. And then we've got 3, cis -45. All right, what do I do with the -2 and the 3? And I get -6, cis 75 minus 45. So what do I do with the actual degrees? What did we do with the last side? Add them. So what's 75 plus -45? 30? Okay. So 30 degrees would put me in the first quadrant, but because it's -6, where am I winding up at? Third quadrant. Okay, so 30 here, 60 here, -6 there. So what should I see as opposite my 30 degrees? -3. Okay, and opposite of 60? -3 radical 3. Okay, you got to remember your ratios. So in the end, we do x's first, right? So it's -3 radical 3 minus 3i. And we actually did cover it. And so we're done. But I am going to give you tomorrow as a work day. So even if you get done with the assignment, make sure you come in with something else to work on, okay? Review is due on Friday. So if nothing else, you can be working on your review tomorrow. Okay? All right.
We decide to use the homework pass tomorrow, do we gotta like?
Gotta let me know. I would prefer you let me know now. But